Binary operations, associative property. Suppose that a known empty set S is closed under a binary operation star. Then A and B elements members of S implies that A star B members of S. A star B can also combine with C, which is a member of S, and we may write this result as A star B star C. The brackets stress the fact that the operation star will combine A and B first before the result is combined to C. Since B and C are elements or members of S, B star C members of set S, and since A is a member of S, A star B star C is also a member of set S. Once again, the brackets ensure that B and C are first combined. The result A star B star C equal to A star B star C may or may not be equal. If, however, A star B star C is equal to A star B star C, then the operation star is said to be associative in the set S. So what this implies is that if we have the associative property usually involves three elements under the same operation. It involves three elements under the same operation, like A, B, C, where A, B, and C are members of a particular set, or in this case, a set of real numbers. So if you take A, B, C, which are members of the set R, and combine them, we will have A star B star C. This implies that A combines with B first, then the result of A operation B will combine with C thereafter. Then for associative property to hold, A star B star C must be equal to A star B star C. So if it doesn't, if this function A star B star C is not equal to A star B star C, that means associative property does not hold under the operation star in this case. So one thing you should know is that associative property always, or for associative property to hold, the combination involves three elements under the same operation. And so for example, addition and multiplication on the set R of real numbers are associative. For if PQ are elements of set R are members of set R, then P plus Q plus R is equal to P plus Q plus R. Same thing also PQ, which is multiplication times R, is equal to P bracket open QR. So what this implies that as when we take from the set of real numbers, let's give these letters real values. Let's say A is equal to 3, B is equal to 4, and C is equal to 2, and they belong to the set of real numbers. So that means A star B. Let's take the operation addition. So if you have 3 plus 4 plus 2 will be equal to 3 plus 4 plus 2. So when we talk about associativity, we mean if we start with these two first, and then the result we get from adding these two and then add it to 2, would it be the same as when we start with these two, the last two first, before adding the result from these 3? If what we get here is the same as what we get here, that means the operation addition is associative. But if what we get here from this simplification is not the same as what we get here after simplification, it means that the operation's addition is not associative. So let's find out. 3 plus 4, if we start off with the first 2 before adding to the last element of the last member of the set R, which is the set of real numbers. 3 plus 4 gives us 7, and then we have plus 2, and then 3 plus 4 plus 2 is 6, 7 plus 2 is 9, and 3 plus 6 is 9. What do you see? You see that if we started with these two first, and then got 7 and then added it to these two, we would get 9. And on the other hand, if we started with these last two members of the set R, we would get 6, and if we add the 6 to 3, we would also get 9. So we see that if we start any order we choose to start from, we would get the same answer under addition operation. So which means that addition is associative. Now let's use the same numbers to test multiplication. Let's say 3 times 4 times 2 will it be equal to 3 times 4 times 2. 3 times 4 is 12. 12 times 2, and then 3. 4 times 2 is 8. 12 times 2 is 24. 3 times 8 is also 24. So what do we see here? We can see that whether we choose to start with these first two, and then the answer we got from starting with these two multiplied by these two by what we have here, we will get 24. Or we choose to first simplify these two, 4 times 2, which is the last two members of the set R, and then the answer we got multiplied by the first member, which is 3, we would still get 24. So what this implies is that the operation multiplication is associative. That's what it implies. So generally, addition and multiplication on a set R of real numbers are associative. On the other hand, subtraction and division over the set R of real numbers are not associative. For instance, 4 minus 3 minus 5 is equal to minus 4, but 4 minus 3 minus 5 is equal to 6. So minus 4 is not equal to 6. And so from this logical conclusion, we can say that P, Q, R being elements of R, then P minus Q minus R is not equal to P minus Q minus R. So what does it mean? It implies that subtraction is not associative. Subtraction is not associative. Similarly, 12 divided by 3 divided by 2 is equal to 2, or 12 divided by 3 divided by 2 is equal to 8. So 12 divided by 3 divided by 2 is not equal to 12 divided by 3 divided by 2. What does this imply? In general, if P, Q, R are members of the set R, then P divided by Q divided by R is not equal to P divided by Q divided by R. And this means that division also is not associative. The operation star is defined on the set R of real numbers by A star B. So A star B is equal to A plus B plus AB over 2. For all AB members of R, A is operation star commutative. So let's go for the operation star to be commutative, then A star B must be equal to B star A. So this condition has to be met before we can say that the operation star is commutative. So let's check if the condition is met. So A star B, and that's what has been given to us here. A plus B plus AB over 2. Now B star A means we're going to change the order where A here will become B and B here will become A. So B plus A plus BA over 2. Now if we follow the order of letters alphabetically, A should come first. So this is same as A plus B plus AB over 2. If you look at what you have here, is the same as what you have here. So you can see that this part is equal to A star B. And so I'm doing that here is B star A, and this is B star A. So this implies that B star A is equal to A star B. So it follows it follows that the operation star is commutative. So B says is the operation star associative over the set R. So for the operation star to be associative over the set R, then E star B star C. Now A star B are elements of the set R or members of the set R, so star C, which is third element, because associative property usually involves combination among three elements of the same set. Three elements which are members of the same set. So, and the same operation but three elements. So A star B will combine with another element which is also a member of the set R, which is C. So if A star B star C is equal to E star B star C, then we can see that the operation star is associative over the set R. But if it is not, then the operation star is not associative. So let's first of all prove this part. So first evaluate E star B star C. Already we cannot carry out the combination of the three elements at the same time, so we must first of all carry out the combination on the first two elements which are enclosed by the brackets. So we say A star B is equal to A star B is this row A plus B plus EB over 2. Now A star B star C will become E plus B plus E plus B plus EB over 2 star C. Now what this implies is that generally when we works with A star B first, because it was inside, because the two elements are inside the bracket, we treated them as two elements. But now that A star B enclosing bracket is combined to C, we are treating this part of it as a single element. So A star B will take the place of A in this general combination, rule of combination. Then C is B. So A star B is A and then C is B. So from the general rule of combination, wherever you have A, that's what A star B will occupy. And you know that A star B is equal to A plus B plus AB over 2. And C is the third element that belongs to the set R. So let's combine this. So A is A star B. Okay. So you know that this part is taking the place of A here. This is the general rule A here. And then C is taking the place of B here. So this will give us A plus B. So in our rule A star B is equal to A, and our A is A plus B. A plus B plus EB over 2. And then plus B. Our B here is C, which is this element plus C plus. Now A again. Remember AB is divided by 2, so bring our 2 out, and then half. Now E here is the whole of this, so E plus B plus EB over 2 times C. Okay, times C. So let's go on. So this will give us A plus B, and this is equal to A plus B plus C plus E B C, A plus B plus E B over 2 plus A B over 2 plus C, okay, plus, so let's simplify what's in the bracket, plus half C times E is AC plus B times C is BC plus BC plus AB times C is ABC plus ABC over 2. Okay, so now we have E plus B plus EB over 2 plus C. Half times AC gives us AC over 2 plus BC. Half times BC gives us BC over 2 plus half times ABC over 2 gives us ABC over 4, because 1 times ABC gives us ABC, 2 times 2 gives us 4. So let's rewrite this. So this will give us ABC over 4 plus AB over 2 plus AC over 2 plus BC over 2 plus E plus B plus C. So this is what you're going to get when A star B combines to star C, or combines to C. So this is the first part of the condition for star to be associative. So let's see if the other part fulfills the condition, if this part is also equal to this part. So next evaluate A star B star C. So now we're going to work on the bracket first. B star C. Remember that the general rule that was given to us is A star B. So I'm going to write, okay, so from, okay. So B star C is equal to, so B star C. Remember that A star B is equal to A plus B plus AB over 2. So where A will take the place of B, B will take the place of A, and C will take the place of B in this equation. So B star C will become B plus C plus BC over 2. We have A star B star C. So now from this general equation, rule of combination, our A is this and our B is the whole of this. So this will give us A star B plus C plus BC over 2. So when you simplify this part, now A star B star C. So if you compare this to this general rule of combination, A star B star B. A is A here and B is B star C, which is this bracket here. We have to simplify this part, which is B star B plus C plus BC over 2. So anywhere we see B in this general equation, we're going to replace it with B plus C plus BC over 2. So take note. So we go, this is equal to A star BC. From our equation, A comes first. A plus B here is B star C, which is B plus C. B plus C plus BC over 2, and then plus. Now here E is, so because we have AB over 2, where B will be equal to all of this, so we're going to bring this 2 out, and it goes 1 over 2 E, 1 over 2 E. Okay, now B here is B star C, which is the all of this, so we got B plus C plus BC over 2. Okay, so A plus B, open our bracket, plus C plus BC over 2. Now 1 over 2 is, that's A over 2. 1 times A is A, so A over 2. A over 2 times B will give us AB over 2. That's A over 2 times C, AC over 2 plus A over 2 times BC. That's A, the numerator will multiply the numerator You know, so multiply it in the length of A times B, so give us ABC. 2 times 2 will give us 4. So let's write this will give us ABC over 4 plus AB over 2 and AC over 2 plus BC over 2 plus E plus B plus C. So let's check. If you compare what you have here, this result to this result here, this is the result for A star, B star, C. If you compare it to the result for A star, B star, C, let's see if they are the same. ABC over 4, ABC over 4, AB over 2, AB over 2, AC over 2, AC over 2, BC over 2, BC over 2, A plus B plus C, A plus B plus C. What can we conclude from this? So we say that, remember what we did here is A star, B star, C. So we say this is equal to A star, B star, C. So we say since A star, B star, C is equal to A star, B star, C, it follows that the operation star is commutative, is associative over the set R. The operation is defined on the set R of real numbers by A. Operation B is equal to A plus B over 2 plus E before A and B members of R. R is a set of real numbers. Show that the operation is commutative but not associative on R. So A, for the operation to be commutative, then E operation B equal to B operation E. So already A operation B is equal to A plus B over 2 plus AB. Let's see what B operation E will give us. Change the order, that is B plus E over 2 plus BE. Here, this also equal to A plus B over 2 plus E B, and this is just what A operation B is. So C is equal to A operation B. So therefore the operation, okay, so since A operation B is equal to B operation E, it follows that the operation is commutative for the operation to be associative on R, then E star A operation B operation C should be equal to E operation B operation C. So let's get this part first. A operation B operation C is equal to A operation this part on A operation B is what you have here. So that will give us A plus B over 2 plus EB operation C. Okay, so if you go by this row of combination is general row of combination, which is A. A here is A operation B. Operation B here is operation C. So from the general formula, A will be this part and B will be C. That's what it implies. So now it will give us equal to E, which is A operation B is equal to E plus B over 2 plus EB, and then plus equal to, because of this 2 half plus B, and B here is C, so that will give us C, and then plus EB. So E is this part A operation B plus E plus B over 2 plus EB times C. Okay, so let's move on. So A plus B gives us A plus B over 4 plus E B over 2 plus C plus A plus B over 2 times C gives us E plus okay, first of all, there's something we need to do here. Let's look at this. Let's look at simplify this part. Let's look at what we have inside the brackets. So come here, A plus B over 2 plus AB. And once again, since 2 plus A plus B plus 2AB. So this will give us A plus B over 2, A plus B plus 2 2EB over 2 and C. And this will be A plus B over 4 plus B over 2 plus C plus A plus B will give us, so this is almost like, so this A plus B plus 2AB is like A over 2 plus B over 2 plus 2AB over 2. Remember, 2AB plus over 2 will cancel, so this will give us EB multiplied by C. Okay, so let's proceed. A plus B over 2 plus AB over 2 plus C plus A over 2 times C will give us AC over 2. B over 2 times C will give us BC over 2. Then AB times C will give us plus ABC. So when we arrange them alphabetically, we're going to have A plus B over 2 plus AB over 2 plus AC over 2 plus BC over 2 plus ABC. So that's the value for A operation B operation C is A plus 4 over 4, and here this also be here because this bracket is A plus B, where B is C here. So this half is 2, which is this 2 is multiplying C 2, so that is C over 2, C over 2, and C over 2. So A plus B over 4, AB over 2, AC over 2, AC over 2, BC over 2, plus ABC, and plus C over 2, which is C over 2. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So let's put this back. A operation A operation, A operation, B operation C. So first thing, from our general rule, A operation B is equal to A plus B over 2 plus AB. So now B operation C will be where B replaces A and C replaces B. So it becomes B plus C over 2 plus BC. So A operation so B operation C will be A operation B plus C over 2 plus BC. That's what you're going to have to do. This will be equal to, now if you go by general rule, A is A, B is this B operation C, which is this part. B operation C, B is B operation C, which is what you have here. Or B operation C, A is here, so B is B operation C. So anyway you have B, anyway you have B in this expression, just put B operation C, which is B plus C over 2 plus BC. It's as simple as that. So let's go by what we have here. So A operation B is similar to A operation B, A operation B or A operation B operation C, where B operation C is B. So A here is E plus B here is equal to, so for that reason I'm going to bring my this 2 out, 1 over 2. So E plus B here is equivalent to B operation C. And what is B operation C? Is B plus C. B plus C over 2 plus BC. So that's what it is. And then, okay, so this part is done, plus B. B is B operation C, which is B plus C over 2, B plus C over 2 plus BC. And then, what is R? And then E times E. So, okay, this is equal to plus E. Okay, let me put E here, multiplied by E. So, this was half. And let's get this part done. So this is half E plus B plus C over 2. So E plus B plus C over 2 plus BC plus E. Okay, let's simplify this part. This will give us, just like we did here, simplify this part. We simplify that part, that will give us B plus C plus 2BC over 2 all multiplied. I'll bring this E here because I can have space here now. Plus E. So A is multiplying everything inside this bracket. So this will give us E. 1 over 2 times A will give me E over 2. E over 2 plus B plus C. 2 times 2, 4 plus BC over 2 plus A times B will give me, now if this is A, B over 2 plus C over 2 plus 2 BC over 2. Remember 2 will cancel out 2. 2 cancel out 2, 1. So I will just write BC. Now A over 2 plus B plus C over 4 plus BC over 2 plus A times B is A, B over 2. A times C is AC over 2. A, B, C. So let me write this. This will be B plus C over 4 plus AB over 2 plus AC over 2 plus BC over 2 plus AC over 2 and plus ABC. So how many terms do I have? 1, 2, 3, 4, 5, 6. I have 6 terms. But let's compare the result of A operation B operation C to the result of A operation B operation C. So from here, b plus c over 4, a plus b over 4, they are not the same. Here is a plus b and here is b plus c. So this part alone shows that they are not equal. Then here we have b over 2, which is the same ac, bc, a over 2. Here we have a over 2, but here we have c over 2. So this term and this term, they are not the same. They are not the same, or they are not equal to c, this term and this term. So for this reason, you can say that this is not equal to a operation b operation c is not equal to a operation b operation c. So it says since a operation b operation b operation c is not equal to a operation b operation c, it follows that the operation is not associative. It's not associative on R. That's what it implies. The operation star is defined on the set R of real numbers by A star B. A star B is equal to A plus B over 5 minus 1. For all A and B members of R, A is R closed under star. Well, since for closure property, you just need to know what kind of set is R. R is a set of real numbers. So if R is a set of real numbers, of course, as long as whatever value A and B would take, if you put them here and we'll divide by 5 and then subtract 1 from that result, we're still going to get a real number. So for that reason, the result of this combination will always give us a third element, which is a member of the set R. Therefore, star is closed. Therefore, star is closed. Star is closed under. So R is closed under. R is closed under star. That's B. Is the operation star commutative in R? For commutativity, say A. For commutative property, A star B is equal to B star A. A star B is equal to A plus B over 5 minus 1. Wherever B star A is equal to B plus B over 5 minus 1, which is also the same as A plus B over 5 minus 1 when the letters are arranged alphabetically. So this part is still the same as what you have. So this is equal to A star B. Therefore, since B star E is equal to A star B, then star is commutative. So star is commutative in R C. Is operation star associative in R? For associative property, A star B star C is equal to A star B star C. So let's simplify this part. A star B star C is equal to, where A star B is already A plus B over 5 minus 1, so this will give us A plus B over 5 minus 1 star C. So yes, that's C. If you compare this to this relation that we're given, which is A star B. So A star B here is for A and C is B here. So in this relation, A plus B, A is 0 of this here, and then B is 0 of this here. So A plus B is divided by 5, so that will be just 1 over 5 over bracket. Now A is A plus 5, A plus 5 over A plus B, A plus B over 5 minus 1, and then plus B, where B is C plus C, and then minus 1 plus C minus 1. So let's simplify that. This will give us 1 over 5, 1 over 5. I'm going to look for the LCM of A plus B over 5 minus 1. A plus B over 5 minus 1. So LCM is 5, A plus B minus 5. And this will give us, okay, so A plus B minus 5. So there will be no need of this anyway. So here 1 over 5 times this, or okay, it's still the same thing. So let's put this here, A plus B over 5 plus A plus B over 5 minus 5 minus 5 plus C. So this will give us minus 1. Now, okay, so this will give us 1 over 5 A over 5 plus B over 5 minus 5 over 5 is equal to 1 plus C. So, and minus 1. So let's open this bracket. It's 1 over 5. A over 5 times. Okay. So let's multiply through. So 1 over 5 times 5 times E. This will give us 1 over 5 times E will give us E over 25 plus 1 over 5. 1 times B will give us B 5 times 5, 25. 1 over 5. 1 times minus 1, minus 1 over 5 plus C. Okay. So this bracket, then minus 1. So this will give us A over 25 plus B over 25 minus 1 over 5 plus C minus 1. Now this will give us equal to A over 25 plus B over 25 plus C minus 1 over 5 minus 1. So that's what you get when for A star, B star, C. So let's see what A star, so A star B star C equal to A star. So for A star B, B star C, so this part here, that A star B is equal to A plus B over 5 minus 1 to B star C. Where B will replace A and C will replace B. That will give us B plus C over 5 minus 1. So this will give us B plus C over 5 minus 1. And that will give us, so this relation compared to these relations where A is where A here is still A because we have A here, and then B is B star C, which is what you have here. So this will give us E 1 over 5 E B. What you have now, B is B star C, B plus C over 5 minus 1 A plus B. So this is okay. 1 over 5 E plus our B is B star C. Will give us B plus C over 5 minus 1 minus 1 then minus 1. This will give us 1 over 5. Now here will be 5 same thing E plus B plus C over 5 minus 1 minus 1. So 1 over 5 times E will give us E over 5 plus 1 over 5 here will be B over 5 plus C over 5 minus 1 minus 1, which is equal to E over 5 so let's 1 over 5 E. Okay, so 1 over 5 E. So 1 times E is going to give us E over 5 plus B over 25 plus C over 25 plus C over 25 plus C over 25 minus 1 over 5 minus 1 over 5 then minus this one minus that one. So here we're going to have E over 5 plus B over 25 plus C over 25 minus 1 over 5 minus 1. So let's compare. What we have here is not the same, or it's not equal to what we have here. So what does that imply? That the operation star is not associative. So we're going to say since E star B star C equals to E star B star C star is not associative. The operation triangle on the set Z of integers is defined by A operation gives so 2A plus 3B minus 1. Determine whether or not the operation is associative in R. For the operation be associative in R, then H and B is equal to A and A operation B operation C. So E operation B operation C is equal to A operation B is equal to 2A plus 3 minus 1. 2A plus 3B minus 1 operation C. This whole part is A and B is C. So anywhere there's A, replace it with A operation B, which is 2A plus AB minus 1. And where there's B, basically C is equal to 2A plus 2AB minus 1 plus 3C minus 1. 2 times 2 is 4A. 2 times plus 3AB will give us 6B. 2 times minus 1 minus 2 plus 3C minus 1. 4A plus 6B plus 3C minus 2 minus 1. 4A plus 6B plus 3C minus 3. Let's check the A operation, B operation, C equals to A operation. So B operation C would be, okay, let's see, dot B operation C is equals to, replace A with B and replace B with C, and this will become 2B plus 2C minus 1. So A operation B operation C is equals to A operation 2B plus 2C minus 1. So if you compare this to this formula here, A is A and B is B operation C. So when we have B in this expression, just put this part here. So this will equal to A. So 2 A is 2A, 2A plus 3. What's our B? Our B is B operation C, which is 2B plus 3C minus 1, again minus 1. So 2B plus 2 times 2B, 6B plus 9C minus 3 minus 3 minus 1. 2E plus 6B plus 9C minus 4. What we have here is not equal to what we have in since A operation B operation C is not equal, and we go to A operation B operation C, it follows that the operation is not associative. The binary operation is defined as A star B A plus B plus EB. So A evaluates 2 star 3 star 4. This will give us 2 plus 2 plus 3 plus 2 times 3 star 4. 5 plus 6 star 4. That's 11 star 4. That's equal to 11 plus 4 plus 11 times 4. 15 plus 44. 59. Add 2 star 3 star 4. 2 star 3 plus 4 plus 3 times 4. 2 star 3 plus 4 7 plus 12. 2 star 19 times 2 plus 19 plus 2 times 19 plus 19 is 21 plus 2 times 19 38 21 plus 38 59. Then B is operation associative. Yeah, since 2 star since 2 star 2 star 4 equals to 2 star 3 star 4. The operation star is associative. So determine whether the binary operation star is commutative and associative on the following. So A star B is equal to A minus B squared minus 2AB. So for commutativity, let's say for commutativity, A star B is equal to B star A. So A star B is equal to A minus B squared minus 2AB. This will give us A minus B, A minus B minus 2AB. A times A is A squared, A times minus B minus AB, minus B times A minus AB, minus B times minus B plus B squared minus 2AB. So A squared minus 2AB plus B squared minus 2AB. So this will give us A squared minus 2AB minus 2AB will give us, so A squared plus B squared minus 4AB. So let's get B star A. B star A is equal to B minus A squared minus 2BA. And so this will give us B minus A, B minus A, B minus A minus 2BA. And this will give us B times B is B squared, B times minus A minus AB minus A times B minus AB minus A times minus A plus A squared minus 2BA is same thing as 2AB minus 2AB. Okay, so B squared plus A squared minus AB minus AB minus 2AB minus 2AB. So if you order is equal to A squared plus B squared minus 4AB. This is equal to A star B. So therefore, since A star B is equal to B star A, it follows that star is commutative. And the star is commutative. I for associativity. So A star B star C is equal to A star B star C. So let's simplify this part first. Evaluate A star B star C. A star B star C is equal to A star B is already from here. A star is A squared plus B squared minus 4AB star C. So from our general equation, from the general rule or combination A star B. A is this bracket and B is this C. So where we have A here, we put this, and where we have B, we put C. So take note of it. So this will give us, so A squared, and this is A. So this will give us A squared plus B squared minus 4AB all squared plus, what's B? B is C plus C, and then what do we have again? Minus 4. So E, A is this, and then B. So we say 4C. So where B is C, so 4C in brackets, because of A is represented by this bracket. So we have A squared plus B squared minus 4AB. Whereas here, this is C squared. This is our A here, and C squares are B here, and then this part is 4AB, where B is C and A is this part, because it's A star B. So this part is A star B. That's it. Now I'm going to do it like this. I want to go further. So next evaluate. Well, if you want to simplify it until it gets to the simplest form, you can do that, but I want to stop here. Next evaluate A star B star C. So A star B star C is equal to A star. So B star C, from this general formula, A will be B and B will be C. So that will give us B squared plus C squared minus 4BC. So this, from the general equation, A star B. So A is A and B is the whole of this bracket. So here we have A squared. Here's A squared, and that's A squared plus. Next we have B squared, and B squared is this. So it gives us B squared plus C squared minus 4BC squared. And next is minus 4. Now what's our E? E is for E. And then what's our B? B is B star C, which is B squared plus C squared minus 4BC. So from here, if you compare, discover that here we have C squared, here we have A squared, here we have A squared plus B squared minus 4AB, here B squared plus C squared minus 4BC. Here we have 4C, here is 4E. So you see that the terms are not the same. Therefore, since A star B star C is not equal to A star B star C, it implies that star is not associative. A binary operation star is defined on a set R of numbers by A star here. A squared B squared minus AB. To show that star is commutative, A for star should be commutative, then A star B because B star A. The A star B is equal to A squared plus B squared minus AB, and B star A is equal to B squared plus A squared minus BA, and this is as A squared plus B squared minus AB, which is equal to A star B. Since A star B is equal to B star E, it implies that implies that star is commutative and do calculate 2 star minus 4. So this formula, A is 2 and B is A is 2 and B is minus 4. So 2 squared plus minus 4 squared minus 2 times minus 4 is 4 plus 16 plus minus 2 minus 4 is plus 8. 4 plus 16 is 20. 20 plus 8, 28. So 2 star minus 4 star 1. So this is 2 star minus 4 squared plus 1 squared minus 4 times 1. Minus 4 gives us 16 plus 1. Minus 4 times 1 is minus 4. Minus 4 times minus 1 plus 4. And gives us 2 star 16 plus 4, 20 plus 1. So 2 star 21. 2 star 21 is equal to 2 squared plus 21 squared minus 2 minus 2 minus 21. 4 plus 441 minus 42. Minus 42. 403. 403. The next one is I 2 star 2 star minus 4 star 1. 2 star minus 4 star 1. These two first. So this will give us 2 squared plus minus 4 squared minus 2 minus 4 1. This will give us 4 plus 16 minus 2 minus 4 minus 8 plus 8 star 1. 28 star 1. 28 squared plus 1 squared minus 28 1. 784 plus 1 minus 28. 757. This is true that star is not associative. So from II and II, we can see that 2 star minus 4 star 1 is not equal to 2 star minus 4 star 1. Therefore, star is not associative. This is C. So D. Solve equation 4 star x equals to 28. And so we're going to solve this using the binary operation a squared plus b squared. So where from a star b equals to a squared plus b squared minus ab. 4 is a squared, so 4 squared plus b is x squared minus 4 times x equals to 28. So 16 plus x squared minus 4x equals to 28. So x squared minus 4x plus 16 minus 28 equals to 0. X squared minus 4x plus 16 minus 28. So 28 minus 16. 8 minus 6 2 minus 12. 5 is minus 12 equals to 0. So here we're going to have minus 12x squared. When we multiply this to this, so 2 factors of minus 12x squared minus 6x and plus 2x minus 6x times 2x will give us minus 12x squared minus 6x plus 2x will give us 4x, which is this. So x squared minus 6x plus 2x minus 12 equals to 0. X squared minus 6x and 2x minus 12 equals to 0. X minus 6 plus 2 x minus 6 is 0. Factor x minus 6 out. X minus 6 and x plus 2 is 0. So either x equals to either x minus 6 equals to 0 or x plus 2 equals to 0. So x equals to 6 or x equals to minus 2. Let R denote the set of real numbers. The binary operation star is defined on the set R by x star y equal to x plus y plus xy for all x and y members of R. A. Show whether or not star is commutative, associative. B. Determine its identity elements. Solution. So for commutativity, yes, x star y must be equal to y star x. So already we know that x star y is equal to x plus y plus xy. So what would y star x give us? So y star x is equal to y plus x plus yx. So rearrange the ordering of the letters. Alphabetically we have x plus y plus xy. So since addition is commutative and multiplication is commutative, either of them will give you the same answer. So this part of it is the same as x star y, which is x plus y plus xy. So we say y star x equals x star y. So therefore, since x star y is equal to y star x, then it implies that star is commutative. So for associativity, okay, x star y star z is equal to x star y star z, where z is also a member of the set R. So let's do this part. So x star y star z is equal to x star y star z is equal to, this part is x plus y, that's x plus y plus x y star z. So from our original combination or rule combination, x plus x and y is x and z is y. So anywhere we have x in this equation, we put the rule of this there, and anywhere we have y in this equation, we put z in place of y. So here x is x plus y plus xy plus y, which is z, and plus x plus y plus xy multiplied by z. So let's open this part. It's x plus y plus xy plus z plus x z plus y z plus x y z. Let's see this. If we have commonality, we can add terms together. Xy, we have xy here, so this will give us x plus y plus z plus xy plus xz plus yz plus xyz. So that's for x star y star z. So let's see if x star y star z will give us the same result. So x star y star z is equal to, and for y star z, our equation is going to become x star. So in the original equation it was x star y, and x star y is x plus y plus xy. So now y star z will be y z y z. We want to do y plus z plus y z. Okay, so this implies that, so in this equation, if you compare it to the original rule that we're given here, x remains x here, and y is y star z. So anywhere there is y, we put this whole part, this function enclosed in the bracket in place of y, and x remains the same. So in this equation, x star y star z becomes x plus, so y will be y star z, which is this, y plus z plus yz plus next part is x y, and that's x, and then y plus z plus y z. Let's expand the x plus y plus z plus y z plus x y plus x z plus x y z. Let's see if we don't have any commonality. We don't have like terms, so just arrange alphabetically. X plus y plus z plus x y plus x z plus y z plus x y z. So let's compare. We'll compare what we have here to what we have here. We discover that they are the same, and therefore this is equal to, so this part x star y star z is equal to x star y star z. So let's give our conclusion. Since x star y star z is equal to x star y star z, it follows that star is associative. So B is only its identity element. Let E be identity element. And we know that as a rule, identity element combines to one of the elements in this rule. So usually identity element must be substituted for the second element, which is y, so it will be x star e. So remember we have x star y equal to x plus y plus xy. So replace y with e. So we have x star e equal to x plus e plus x e. Now but x star e must be equal to x. That's the rule definition for identity. Is any number added or multiplied by a number such that it gives that same number. So x star e should be equal to x. So this part here is equal to x, so we'll put x in place of this. So x equal to x plus e plus x e. Now we bring x to this side, collect like terms, x minus x e plus x e. So here's 0 equals to factor e out 1 minus x. So divide through by e minus x. We're going to have e 0 minus 1 minus x, which is equal to 0. Therefore, the identity element is 0. The binary operation star is defined on the set R of real numbers by A star B is equal to A plus B minus 2AB, where A, B are members of R. Determine whether or not star is closed. 2. Commutative. 3. Associative on the set R. Solution. Closure property. For closure property, we discover that if since this binary operation star is defined on the set R of real numbers by A star B, plus A plus B minus 2 AB. For closure property, it says that uses rule of combination. If this if we get a third element, if we got the third element from this part of the equation, and that third element belongs to the set R of real numbers, it means that the operation star is closed. But if we use this function to get a third element, and that element does not belong to the set R, which is a set of real numbers, it means that the operation star is not closed. But in this case, there's no number that we're going to use that we're going to get a number which will not belong to the set R, except that number is a complex number and it cannot be outside the range of this set. You can't get a complex number from using this operation. For instance, if we use 2 and 3, 2 and 3 will give us 2 star 3. So if we use this function, A is 2 plus 3 minus 2 times 3 times 2 times 2 times 3 is 5 minus 2 times 2, 4 times 3, 12 minus 7. Minus 7 is a real number, and so it belongs to the set R. So there's no number that you're going to use that will not belong to the set R except complex numbers, and complex numbers are of this nature. minus root 7 or minus root minus 64. So these are complex numbers. These are numbers that are outside the range of the set R. They are not real numbers. They are called imaginary numbers. But there's no way you can, for this particular combination, we cannot get imaginary numbers of this nature. So we conclude by saying that star is closed. Yeah, the set R is closed under binary operation star, under the binary operation star. So figure 2, commutative. For commutativity, A star B should be equal to B star A. A star B is already A plus B minus 2AB. And remember, this is addition, it's commutative, this multiplication is commutative, but let's define that B star A is change the order B plus A minus 2BA, which, since this is commutative and this is commutative, it does not make any difference. So this will give us A plus B minus 2AB. And then this is equal to A star B. So since A star B is equal to B star A, it implies that star is commutative. Star is commutative. Figure 2. For associativity, A star B star C is equal to A star B star C. So let's see. A star B star C will give us A star B star C will be, and A star B is equal to A plus B minus 2AB star C, where this is A here and C is B here. So, and that will give us from our equation A would be equal to this A plus B minus 2AB plus B, which is C, plus C minus 2 A plus B minus 2AB, and then B, our B here is C, which will multiply by C. We can get a 2C. 2C here. So, and this will give us, open this will give us A plus B minus 2AB plus C minus 2AC minus 2BC plus 2 plus 4 minus 2C times minus 2AB plus 4ABC. So this will give us A plus B minus 2AB minus 2AB minus 2AC minus 2BC plus C plus 4ABC. So that's what we're going to get from, that's what we got from A star B star C. Now let's check if this part would also be equal to this. So A star B star C equal to A star. So for B star C, compared to this relation, B is A and our A is B and our B is C. So that will give us A B plus C minus 2BC. Okay, so now this bracket is our B here and our A is still A here. So that will give us A plus B is B plus C. So B plus C minus 2BC minus 2bc and minus 2a, and then b is c here, is this part which is c, b is c. C is b plus c minus 2bc. So let's open our bracket. A plus b plus c minus 2bc minus 2a times b gives minus 2ab minus 2a plus c gives minus 2ac minus 2a minus 2a minus 2bc gives plus 4abc. So this a plus b plus c, a plus b plus c, a plus b plus c give us minus 2ab minus 2ab minus 2ac minus 2ac minus 2bc minus 2bc plus 4abc. So if you compare, discover that this part is same as this part, only that in this case I wrote my plus c here, I didn't put it here. So a plus b plus c, then minus 2ab minus 2ac minus 2bc plus 4abc. That's what you have here. So this is also equal, this part is equal to a star b star c. So we say since a star b star c is equal to a star b star c, it follows that star is commutative, or so that star is associative. Star is associative on the set R. On the set R.